Hello, I am one of the tutors with the Genius Academy, and I will be taking you through the 2024 predicted paper for GCSE Mathematics. Before we start, I just wanted to provide a small introduction to the Genius Academy. So, we are a tuition centre, one of the fastest growing centres in the UK, and we are a team of qualified and experienced tutors who support over 500 students with tutoring, revision notes, and predicted papers for a range of UK exam boards, including AQA, Edexcel, and OCR. We provide tutoring for in one-to-one classes, group classes, and paper classes for students sitting 11 plus, 13 plus, GCSE, IGCSE, as well as A levels, as well as the key stages. And we provide tutoring for a range of subjects that include maths, further maths, the sciences, English, geography, psychology, etc. And our sessions, they cover the following: so theory, worked examples, past paper questions with answers, as well as the latest past paper questions and answers, and we provide our own predicted papers, mock papers, homework, revision materials, and revision videos like this one. And we aim to support our students to help them achieve the best they can do. That was just a little introduction, and now I will walk you through the paper. Okay, so the paper, this is ideally to be completed in an hour and a half, and it is out of 100 marks. It is a calculator paper, and it is aimed at higher students. So for question 1, we need to write 700 as a product of its prime factors. In order to do this, we will draw a prime factor tree. So we've got 700. We can list out some of its factors. So we can have 350 and 2. 2 is a prime factor, so we can circle it. 350 we can split into 50 multiplied by 7. 7 is prime. 50 we can have as 10 multiplied by 5. 5 is prime. 10 can be split into 5 multiplied by 2, both of which are prime. So the 700 as a product of its prime factors will simply be 5 times 5 times 2 times 2 times 7. So this can be simplified into 5 squared multiplied by 2 squared multiplied by 7. Moving on to question 2, we've been given a calculation and we just need to calculate it to 3 significant figures. For this one, you can simply put it in your calculator, and ideally you want to write out the whole calculator display, or at least 5 to 6 decimal places first. So if we put this into a calculator, we will get 0.21961878, and then to 3 significant figures, this is simply 0.212. Moving on to question 3. So we have an algebraic Fibonacci style sequence. We've been given that the first term is p, the third term is 7, and the fifth term is 16. And we need to calculate the value of p. First, we can write out our sequence. So the first term is p. For the second term, since we don't know what it is, we'll just label it as x2. The third term is 7. The fourth term we will label as x4. And the fifth term is 16. So a Fibonacci sequence is basically where you add up the previous 2 terms to get the third term. So in this case, we can establish that p plus x2 equals 7, x2 plus 7 equals x4, and 7 plus x4 equals 16. So by the third equation, we can establish that x4 is equal to 9. And then subbing this into the second equation, if I label them 1, 2, and 3, For the second equation, we can then say x2 plus 7 equals 9. So x2 is equal to 2. And then bringing that back and subbing it into the first equation, we can say that p plus 2 equals 7. So p is equal to 5. For the fourth question, we have two shapes, one inside a pentagon, inside a hexagon, and we have been asked to find the angle of FGE. So for this question, first of all, we'll start off by labeling our angle so we know what we're looking for. So if I draw a line here, perhaps in red, and this angle here is what we're looking for, so X. To start off, what we can do is we can try and find the internal angles of both the hexagon and the pentagon. So the standard equation for internal angles of a polygon is equal to n minus 2 multiplied by 180 divided by n. So for the hexagon, n is equal to 6. So then 6 minus 2 multiplied by 180 divided by 6 again is equal to 120. For the pentagon, n is equal to 5, with n being the number of sides. 5 take away 2 multiplied by 180 divided by 5 is equal to 108. So labeling this in our diagram, we can say that this is 108 degrees, whereas this is 120 degrees. And then we can, using these facts, we can say that FEG, so this angle here, if I label that Y is simply equal to 120 take away 108, which is 12 degrees. Now, since we know that these are both a regular pentagon and a regular hexagon, we can say that sides FE is equal to EG. That makes the triangle FGE isosceles. So triangle FEG is isosceles. So FGE is equal to GFE, which is 180 take away 12 divided by 2, and this gives us 84 degrees. So the angle we're looking for, FGE, sorry, that should be a G there. FGE is equal to 84 degrees. Okay, so moving on to question 5. Here we are told that two shapes, P and Q, are similar shapes. Shape P has an area of 700 centimeters. Shape Q has an area of 300 centimeters. And we're told that the difference between the volume of shape A and the volume of shape B is 500 centimeters. And now we need to calculate the volume of P and Q. So, if we set this out in terms of ratios, P to Q for area is 700 to 300. Now, we can simplify this down to 7 to 3. And this is the ratio for the area of P to Q. Now, to find the volume ratio, what we would do is square root 7 and then cube it. Oh, it should be 3 for the other one. And this will be our ratio for the volumes. So this is the same as 7, 3 to the 2, 3 to the power 3 over 2. And this is the same as volume 1 to volume 2, so the volume of P to volume of Q. Now, in order to find out what the individual volumes are, we can do V1 divided by V2, which is equal to 7 to the power 3 over 2, divided by 3 to the power 3 over 2. And we can rewrite this as 7 over 3 all to the power 3 over 2. This is just rewriting the fraction. Now, we can then rearrange the fraction as V01 over V2 is equal to this. We can say that V1 is equal to V2 multiplied by 7 over 3 to the power 3 over 2. Now we've got V1 in terms of V2. We can now use the information in line 3, so that the difference between the volume of shape P and the volume of shape Q is 500. So we can say that V1 take away V2 is equal to 500. Now we've got two unknowns, but we do have V1 written out in terms of V2, so we can substitute this in. And if we do that, we get 7 over 3 to the power 3 over 2, V2, take away V2 is equal to 500. Now we will factorize out V2. So 7 over 3, 3 over 2, take away 1 is equal to 500. And then V2 is equal to 194.9906. We've just divided both sides by the brackets here. So 7 over 3 to the power 3 over 2, take away 1. And now to find V1, we go back to this equation here, that 7 over 3 to the power 3 over 2 multiplied by V2. So if we do that, we shall get 694.9906 as our final answer. So V1 is the volume of P, V2 is the volume of Q. And that is our final answer. Okay, moving on to question 6. Here we have a circle and we have a few different triangles per se. Okay, so A, B, C, and D are points on a circle. O is the center of the circle. AO and DC are parallel, and the size of angle AOD is 57 degrees. And now we have to find angle ABC. So this angle here, which I will label as X, is what we need to find. Now there's multiple ways to answer this question. This is just one approach. So given the information that we have, we can say that if I join these two lines up here, we can say that the triangle AOD is isosceles. This is because AO is equal to OD because they're both lines from the center of the circle to the circumference, so they are both radii. Now, we can also say the same about triangle OCD. If I join up these two lines here, that makes a triangle, and this is also isosceles. Now, so we've got two isosceles triangles. We've established where the lines are similar or form the radius. Now we can try and calculate missing angles. So since we know AOD is 57 degrees, we can also say that since AOD is equal to CDO, they are both 57 degrees. And then because it's an isosceles triangle, CDO is equal to OCD, so they are also both 57 degrees. So this is 57, this is 57. So they're both base angles in the isosceles triangle. So to find the angle DOC, this is simply 180, take away 2 lots of 57, and this is equal to 66. So this angle here is 66. Now, for the final part of this question, we can use circle theorem. So it might not be so clear to see now, but if I highlight it, you've got this shape here. And we also have the circle theorem that states for the shape in yellow, the angle at the center is twice the angle at the radius. So AOC is equal to 57 plus 66, which is 123. Now, if we divide that by 2, the angle ABC is equal to half of AOC, which is 1 over 2 multiplied by 123, which is 61.5 degrees. And this is our angle ABC. If I scroll back up, so this angle here is half of this big angle here. Okay, now moving on to question 7. Here we've been given an equation with 4 different unknowns, and we just need to rearrange to make R the subject. So first of all, I can move P to the other side, so K plus P is equal to R squared plus R squared. What goes over n, that one's over n, and we can put it over the same denominator. So n r squared plus n r squared over n is equal to k plus p. And if I factorize the top, r squared n plus m over mn. So now to rearrange to make r squared the subject, mn bracket k plus p divided by m plus n is equal to r squared. And then we need to square root both sides to make r the subject. So we can say that r is equal to the square root of m n k plus p over m plus n. And that is our final answer. Moving on to question 8. We need to express this very long, messy looking fraction into a much simpler one. And the easiest way to go about this is to factorize everything. So if I factorize this, I get 3 bracket x plus 7. Here, this is the difference of 2 squares. So factorizing this, I can give x plus 5, x minus 5. For this bottom fraction, I can factorize it as x plus 7, x minus 5, and here x plus 5, x minus 2. So if I rewrite the fraction now, 3 x plus 7, x minus 5, x plus 5 over and now what I can do is just cancel out everything that is appears in both the numerator and the denominator. So this goes, this, and this. And now we are simply left with 3 over x minus 2. and this is our final answer. Okay. Question 9. Here we are dealing with graph transformations. So for the first question, we have, in the question we are given that y equals f of x and the maximum point of the graph is 5, 2. For part A, we need to shift this graph by this here. So f of x plus 2 essentially means that we need to move the x coordinate down by 2. If it says plus 2, you do minus 2. So then we can say that 5 minus 2, 2. So our final coordinates are 3, 2. For part B, our transformation, this is quite a few, so essentially 3 transformations. The plus 4 means that we need to shift the y coordinate up by 4. The x minus 2 means that we need to shift the x coordinate down up by 2, and the 3 outside of the f of x means that we need to multiply our y coordinate. So essentially what we are doing, 5 plus 2, 3 multiplied by 3, 3 multiplied by 2, 2 being our y coordinate, and adding 4. So then we get 7, 10 as our final answer. Okay, so for question 10, this is a proof-based question. We have been told that the sum of 2 consecutive cube numbers will always be odd. And here we've been given our cube numbers, n cubed and then n plus 1, all cubed. The easiest way to do this is to expand our brackets to see what we have. So we have n cubed plus n plus 1, all cubed. Now expanding this, what I'm doing now is I've expanded all the brackets, so I just need to simplify it now. So once we've simplified, we are left with 2n cubed plus 3n squared plus 3n plus 1. Now if I try to factorize out 2, I get n cubed plus 3 over 2n squared plus 3 over 2n plus a half. So we can say that it can't be an even number because when we factorize it, we are left with a half here. And we've got 3 over 2, got 3 over 2. Therefore, it is not divisible by 2. So it is always odd. Okay. So question 11. Here we have 3 different equations. We have x squared plus y squared is less than 25, x plus 5 is greater than or equal to 1, and y is greater than or equal to 1. So here we have 3 different inequalities that we need to draw on a graph. So first of all, if we look at the 3 equations, we can say that this is a line, this also forms a line, but this is something slightly different. This is a circle. So this equation of a circle, we can say that it has a center, 0, 0, and it has radius, square root 25, which is 5. And looking at the inequality sign, it's less than. So in this case, when we draw our circle, we must remember to draw a dotted line rather than a solid line. So my circle may not look the best. And that is our circle. The next line we will deal with is the y is greater than or equal to 1. So that's just a straight line at y equals 1 here, like so. And our final line is x plus y is greater than or equal to 1. So we can rewrite this as y is greater than or equal to 1 minus x, which is slightly easier to visualize. So drawing that line out, the dots are just the points that lie on the line. And since I'm drawing this graph freehand, it will not look the neatest, but in an exam you will draw it using a ruler, so your lines will be straight. So now we've dealt with all the lines, we know we can now go about establishing what the area is that we want to shade in order to that satisfies all these inequalities. So if we look at the first inequality, because it's all the points that are less than 25, we can say that it's all the points within the circle. So we can restrict our area. With the second inequality, it's y is any point that is bigger than 1 minus x. So it's any line, any point that's to the right of our diagonal. And for y is greater than or equal to 1, it's all the points above the line. So considering all this, the area we want to shade is this one here. And this is the area that satisfies all the inequalities. Now, moving on to the next question. Question 12. So here we're dealing with direct and inverse proportion. So the question states, t is inversely proportional to r cubed, and when t is equal to 50, r is equal to 2, and we need to find r when t is equal to 250. So to write out the first line, this simply means t is equal to k divided by r cubed. This is because it is inversely proportional. So what we can do first is, using these two values here, we will calculate the value of the constant k. So t is 50, k is our unknown, and then 2 to the power 3. So k is equal to 50 times 8, which is 400. Okay, now what we need to do next is find r when t is 250. So t is equal to 400 over r cubed. T is 250, this is 400 over r cubed. Now we just need to find out what r is. So if we rearrange to make r the subject, r cubed is 400 over 250. R is the cube root of this, and this should give us 1.169 to 3 decimal places, so roughly 1.17 to 2 decimal places. And that is our answer. Question 13. So we have a trapezium PQRS, and it has been split into two triangles PQR, PSR, and we've been given a few sides, no angles so far. And we need to find the area of the triangle PQR. So, starting off, what we can do is try to find a few angles. We've got some equations that we can use to find the area of the triangle. So, for area, we have that half times A times B times sine of angle C. So for PQR, we could use a half times 12.3 times 7.7 times sine of C, with this being C, but we obviously don't have an angle there. So we need to use the triangle here to try and fill in some gaps. So if I label this angle as alpha, cos of alpha is equal to b squared plus c squared minus a squared over 2bc. So substituting in the numbers, 15 squared plus 12.3 squared, take away 8.2 squared, over 2 times 15 times 12.3. So cos alpha is equal to 0.8375, and then angle alpha will be equal to 33.12 degrees. So we found one angle so far. And we can also say, because PQ and RS are parallel, the angle QPR is also alpha. They're alternate angles. Okay. So we found one angle in our triangle PQR, but it's not the angle we need. So what we can do is we can try and use the sine rule to try and find a few more of the missing angles. Now, since we don't have the side PQ, we can't find angle C using the sine rule, but we can find angle PQR. So what I will do is I will label this angle beta, and we can say that, let's see, 12.3 over sine of beta is equal to 7.7 of sine 33.12. Now, if I rearrange this, sine of beta is equal to 12.3 multiplied by sine of 33.12 divided by 7.7. So this is equal to 0.8728. In this here so far, we have that beta is equal to 60, oh no, not 60, 60.78. But looking at the diagram, we can establish that beta is indeed a obtuse angle. So what we need to do is we need to do 180 take away 60.78 to get 119.22 as our angle beta. So that is beta. Now, using angles in a triangle at up to 180 degrees, we can find C. And this equals 27.66. So then, if we substitute this angle back into our equation over here, so what I'll do is I'll rewrite it down here. And this equals 21.98 centimeters squared, which is 22 centimeters squared to the nearest whole number. So here we had to use a few different trigonometry rules to come to the answer. Okay. Moving on to question 14. So here we've been given a cumulative frequency table, which has given us information about the ages of 90 people working for a company. So to start off with, we need to draw the cumulative frequency diagram. To do this, on the x-axis we have the ages, which is provided to us in the class intervals, and on the y-axis we have the cumulative frequency. In order to plot this graph, what we need to plot for the x-axis is the end points of each class interval, so 30, 40, 50, 60, and 70. So if I go to plot them, so at 30, it's 18, 40 is 38, 50 is 59, 60 is 84, and 70 is 90. Okay, so then if we join up our points, for part B, we need to use our graph to find an estimate for the median and the interquartile range. So to start off with the median, this is the halfway point. So this is basically, we've got 90 values, 90 people. So if we do 90 divided by 2, this is the 45th value that will give us the median. So obviously in the exam, please use a ruler. If I draw across there and read down, this is roughly, should be around 43 years. Now, the interquartile range is slightly trickier. For this, the equation we need is the upper quartile take away the lower quartile. So we need to find two values before we can find the interquartile range. For the upper quartile, this is the 75th value, so the 3/4 mark. So we are looking for the 67.5th value. It is somewhere here. And that is roughly 52 years. And for the lower quartile, this is the 25th value. Not 25th value, the 25th percentile. So the 1/4 mark. So the 22.5th value, which if you read off your graph, should be roughly 32. So then for the interquartile range, we will do 52 take away 32, which gives us 20 as our interquartile range. Moving on to question 15. So we have two different functions, f of x and g of x. For part A, we need to find f of 3. So here we will just substitute in the place of x, 3. So 3 bracket 3 squared plus 4 bracket 3 minus 2. And simplifying this, we should get 37. B. F of g of x is equal to 2, and we need to solve this. So g of x is simply 2x plus 5. So we have f of 2x plus 5 is equal to 2. So in f of x, we just need to substitute this into wherever there is an x. So and if we expand and simplify, we will get so if we move the 2 from the right-hand side over to the left-hand side and simplify everything that we have, we will get 12x squared plus 68x plus 91. Now we need to solve this equation to find our two values of x. Since this is kind of hard to factorize, we can use the quadratic formula. So this is minus b plus or minus the square root of b squared minus 4ac over 2a is equal to x. Now if I substitute it in, I will get you can just stick this in a calculator and it will give you both values. The first time round use plus, the second time round use minus, or vice versa in here to get your two values, and you should get minus 2.2 and minus 3.5 as your x values. Okay, and then for part C, we need to find the inverse function for f inverse of x. So here. So f of x is equal to 3x squared plus 4x minus 2. So we can replace the f of x with y. And then now what we can do is solve this quadratic equation for the value of x. So we'll just go back to using the quadratic formula. So that x is equal to that should be a 4 there, minus 4 plus or minus b squared is 16 minus 4, a is 3, c is minus 2 minus y over 2 times 3. So if I simplify this, I should get minus 4 plus or minus the square root of 16 plus 12 bracket 2 plus x all over 6. And this is our final answer. Of course, there are other ways of doing this, but this should be the answer you get at the end. So F. Okay. And then moving on to question 16. So for part A, what we need to do is complete the square. So in order to do this, what we will do, we have x squared minus 4x minus 3. So x, oh that should be a plus. So x plus 2 squared minus 2 squared minus 3. This 2 is basically the b term divided by 2, and we need to take away the square of this, as all we want is the x squared plus 4x terms, not the plus 4 as well that will come at the end. So we will take away that plus 4 to balance. Now simplifying this, minus 2 squared is minus 4, so minus 4 minus 3 is minus 7 equal to 0. And this is our completed the square form. For part B, we have two equations. We have x squared plus 4x minus 3 is less than or equal to 0. And we have x squared minus 4 is greater than 0. And we need to find the values of x that satisfy both. Now the solutions for the first equation it can be obtained by using part A. So is equal to 0. So if we make x the subject, we will get 7 square root minus 2. So this, if we rewrite it, is minus 2 plus or minus the square root of 7. And the solutions for x squared minus 4 is plus or minus 2. Now if we draw the graphs, minus 2, 2. Now for the values we want, it's all the values that are greater than 0. So we are looking at this bit here and this bit here. And the inequalities that satisfy this are x is greater than 2 or x is less than minus 2. Now for the second graph, minus 2 minus root 7 is this solution here, and here is minus 2 plus root 7. And the values we are looking at are all the values less than or equal to 0. So that includes the solutions in here. So then the inequality that we need that satisfy the x values that satisfy the inequality for this graph is minus 2 minus root 7 less than or equal to x less than or equal to minus 2 plus root 7. Now to find the inequality that satisfies both the equations, we can draw a number line. 1, 2, 3, 4. So if we draw a number line to picture our solutions, we can say that this is minus 2 minus root 7 minus 2 plus root 7 and 2. So this is the inequality for the first graph. And this is the inequality for the second graphs. So if we look at what satisfies both the equations, it will be the inequality minus 2 minus root 7 less than or equal to x less than minus 2, because that represents the region here where both lines overlap. Okay, moving on to question 17. So this is a case of quadratic simultaneous equations. So we have two equations, one linear, one quadratic, and we need to solve them to find x. Now we can say that x is equal to 5 minus 2y. That is simply just rewriting the first equation. And then we can substitute this into the second one. But before we do that, we can kind of simplify the problem a little. This equation here, we can factorize. So we can factorize it into x plus y, which is the same as x plus y squared. So the second equation now is x plus y squared is equal to 20. And our first equation is x is equal to 5 minus 2y. So if we substitute this into this, 5 minus 2y plus y squared equals 20. 5 plus y all squared is equal to 20. Oh, sorry, that should be a minus. So then if we expand this, we will get y squared minus 10y plus 25 is equal to 20. And if we shift everything over to the left-hand side, equals 0, and we can simply use the quadratic formula once again. So just to remind you, minus b plus or minus square root of b squared minus 4ac all over 2a. And if we do this, our solutions will be 10 plus or minus 10 squared minus 4. A is 1, C is 5. And these should give us the values 9.47 or 0.528. And then to find x, we will substitute 5 minus 2 multiplied by 9.47, and this gives us minus 13.94. And for our second x value, 5 take away 2 multiplied by 0.528 is equal to 3.944. So these are our y values, and these are our x values. Okay. Question 18. So this comes under the topic of iteration. So for part A, we've been given a formula and we've been told that x0 is equal to 1.5 and that we need to find x1, x2, and x3. So what you will do here is to find x1, we will need to substitute in x0 cubed minus 2x0 plus 5 all over 3. And we're told that x0 is equal to 1.5, so we will substitute in 1.5 wherever we see an x0. And if we do this and stick it in a calculator, we shall get the value 1.338531534. Now, to find x2, this time we need to substitute x1 cubed minus 2 x1 plus 5 all divided by 3, and in the place of x1 we will substitute this, and putting it into a calculator we will get 1.254477217. Then for x3 you repeat the same procedure. In this time, in place of x2 we will substitute in the long decimal this that we get here, and we shall get 1.220004478. And then for part B, explain the relationship between the values of x1, x2, x3 and the equation x cubed minus 3x squared minus 2x plus 5. So essentially, x1, x2, and x3 are the approximate solutions to the equation. We can see this by rewriting our equation. So we have x cubed minus 3 squared minus 2x plus 5. Now, If I rewrite it and bring 3x squared to the other side and now try to make x the subject using that, I can say that first I will divide by 3. And then if I square root it, this is the iteration formula that we were given in part A. And then x1, x2, and x3 will be the approximate solutions for the equation. Okay, moving on to question 19. Here we have a table of values. So we've been given f of x is equal to minus 2x squared minus 4x minus 2. Now to find the values for minus 3, minus 2 up until 3, we just need to substitute them into f of x and we should get the values 28, 14, 4, minus 2, minus 4, minus 2, and 4. So if I draw out that graph, now mine will not look the most accurate. So 28 will be somewhere there, 14 somewhere here, 4 somewhere further down, 0 is minus 2, 1 is minus 4, 2 is minus 2, 3 is 4. And that is our graph for f of x. Now, for part C, we've been told to use the graph to solve the following equation. Now, it might not look so obvious as what to do, but what we can do is rewrite the equation that we've been given here in terms of f of x. So, f of x was 2x squared minus 4x minus 2. Now, what we need to do is look at what we need to do to f of x in order to create this equation here. So, in order to balance out the x values, we need to add on 3x. And in order to balance the constants, we need to take away 3. And then if you simplify this, you will get this equation here, which is the equation we need to solve. Now, what we can do is rearrange it. And if I bring whatever we shift f of x by to the right-hand side, I get 3 minus 3x. Now, what I can do is I can draw this graph. It's a linear straight line with gradient minus 3, y-intercept 3. So if I draw that line out, right, I'm going to draw it out rough, but obviously when you draw it more accurately with a ruler, you should get two solutions. One is roughly here, and one is here. Now, with a more accurate graph, you'll be able to read your solutions off more accurately, but our solutions, we should get x is equal to 1.85 and minus 1.35. Now, if you are struggling to draw your graph and to solving it that way, what you can do is use the quadratic formula in this equation here and solve it like that, just to find your x and y values. You may not pick up all the marks because they have asked you to use the graph to solve it, but you may pick up a few marks for the final answer. So to just recap, where the two lines meet, where they intersect, they are your solutions to the equation. Now, question 20. Here we are looking at upper and that should say lower bounds for n. We've been given the equation for n, and we've been told that r has been measured to 3 significant figures, x to 1 decimal place, and y to 1 decimal place. So what we can do now is to figure out the bounds of our values. So for r, it's 7.53. I put upper bound, lower bound even, upper bound. Now, because it's been measured to 3 significant figures, we can say that the lower bound will be 7.525 because that will round up to 7.53. And the upper bound is 7.535 because that will, with the inequality signs, it will round down. And we can do the same for 52 and 43. So for 52, the upper bound will be 52.5, the lower bound 51.5, 43 is 43.5, 42.5. Now, to find n, upper bound, we will, for the numerator, you want to substitute in the biggest value you can calculate for r and for x. So we will have 7.535 plus 3 sine 52.5. And for the denominator, you want to use the smallest value. This way we can maximize the value of n. Oh, that should be 42.5. Apologies, because we want to maximize n, we need to use the smallest number possible in the denominator to find the maximum value. And then for n, lower bound, here we will use the smallest values possible in the upper bound, in the numerator, and the biggest value possible in the denominator. And just to calculate these quickly, here we get 1.3861, and here we will get 1. Oh, apologies. So in our denominator here and here, we should have used 43.5 and 42.5. So then, if we were to calculate our values again, we will get 1.397 and 1.383. That was a mistake on my part, so I just want to correct the denominator value for the upper bound. For the angle of cos, we will use 43.5, and for the lower bound, we will use 42.5. Okay, now moving on to the next question. 21. here we have the area of the base of a cone divided by the total surface area of the cone. And we have a cone here, A, B, C. Okay, so for the numerator, it is the base of the area of the base of the cone. So this is just a circle. So that is just pi r squared is area of base. And then for the total surface area of the cone, that is just the equation, pi r r plus L. So this is surface area. And we know that the one divided by the other is equal to 2 over 5. So first we can cancel the pi and we can cancel an r. So we have r over r plus L is equal to 2 over 5. Now if we cross multiply, and rearrange, so we bring the r's to one side and the L to the other, we have this equality here. Now what we've been asked to do is to find the angle ABC, so that's this theta, and that is the angle of a triangle here. Now what we can do is if we split it down the middle, we have two right angle triangles. The base here, so half of it is r, and the length here is L, so L is the height. So to find the angle theta here, if I use sine theta, I can say that sine of theta is equal to L, mislabeling. So L is the length here. So if I use sine theta is equal to opposite over hypotenuse, if I substitute the values in, it will give me L over R. Now, if I rewrite this inequality here to get L over R, I can say that 3 over 2 is equal to L over R. So sine theta is equal to 2 over 3, because we want R over L. Apologies for my mistakes. That should be R over L. We get 2 over 3, and this angle is simply 41.81. Now for angle ABC, this is 2 times theta. So for 2 theta, it is 2 multiplied by 41.81, which is equal to 83.6 degrees as our final answer. So we have a cone, the length of the side is L and the radius is R. Just wanted to clarify that. And we can use SOHCAHTOA to find the angle theta. And 2 times the angle theta is our angle ABC. Okay, so question 22. This is more of a probability question. So we have that James has 7 cards. He takes 2 of them at random, and he wants to work out the probability that the product of the 2 numbers is odd. So if we look at our combinations, odd multiplied by odd is odd. Odd multiplied by even will give you even. Even multiplied by even will also give you even. So we need to find the probability that we get 2 odd cards. If we look at our numbers, 1 is odd, 3, 5, 7. So 4 out of 7 cards are odd. So if we pick one odd card, that's 4 out of 7, and the probability that we pick another odd card will become 3 out of 6. This is because we are not replacing the card. So the total number of odd cards goes down by 1, and the total number of cards we have left to choose from goes down by 1. So if we multiply this, we get 12 over 42, and simplifying this, we will get 2 over 7 as our final probability. Now, okay, moving on to question 23. So we've been given a speed time graph for a car. For part A, we need to find the average deceleration of the car between 0 and 40 seconds. Now what we can do here is draw a straight line between 70 and 40, between 0 and 40 seconds. So here and here. Please draw a straight line with a ruler, not freehand, but roughly that. And we need to find the gradient. So here we will get gradient is change in y over change in x. So 70 take away 40 over 0 take away 40. So, to be fair, if it's 0 take away 40, we can just leave it for now. Because we've been told it's deceleration, we don't need to account for the sign. But we can do anyway. This will give you 30 over, minus 30 over 40, which is minus 0.75. The minus indicates that it's decelerating. And because we've also already been told it's deceleration, we can just say 0.75 meters per second squared. Now that is the average deceleration. For part B, we need to find or estimate the time when the instantaneous deceleration is the same. Instantaneous deceleration is the deceleration at a specific point t. Time is equal to t. So that's when we have to draw a tangent so that the gradient of that tangent will also give us 0.75. Okay, so now to work that out, we can use our knowledge of graphs. So we know that for a graph, if two graphs are parallel, they will have the same gradient. So what we need to do is to find a point on the graph where the line that we used for the average deceleration is parallel to the instantaneous one. So if I draw a line roughly here, you can see that at the point here, it's parallel. That is the point that we're finding the gradient for. So if I draw a line down, please do this with a ruler, it will be a lot more accurate. You find that the time is roughly 25 seconds. Now for part C, we need to use 3 strips to estimate the distance travelled in the last 30 seconds of the car, so between 40 to 70 seconds. So here, if I draw it in red, the 3 trapeziums, that's trapezium 1, trapezium 2, trapezium 3. So we need to find the area of 1, 2, and 3. Now for the area of a trapezium, that is a half times the height times a plus b. So a and b, this is a, this is b, this is the height. Okay, since they all have the same height, we can combine the equation. So we can say a half times 10, which is the interval, multiplied by the first height is roughly 40 plus somewhere here, something like 26, 27 plus 27 because that is also the top of the trapezium 2. And then that's trapezium 1. And plus 20. Now, if we simplify this, we can and this will just give us 790 meters as our final answer. Okay. Question 24, so bearings. We've been told that the figure shows position of two buildings A and B. The bearing of A from B is 128 degrees, and we need to calculate the bearing of B from A. So, bearing of A from B indicates this angle here as 128. Now, if we continue this line, we can say that this angle here is equal to this angle here. And by angles in a straight line, we can say that 180 take away 128 is 52 degrees. And so 52 degrees is the angle here. Now, to calculate the bearing of B from A, we are looking at this angle here, right? So, what we will do is 360 take away 52 to get 308 degrees. And this is our angle. So this is the bearing of B from A. Okay, moving on to our last question, vectors. We've been given a triangle. We've got that OA is little a, OB is little b. We've been given the point P such that A to P from P to B is the ratio 1 to 6. So here is 1/7 of the line. This is 6/7 of the line. And we've been told that O to P is T multiplied by 6A plus B. And we need to find T. So, to find O to P, we can do O to A plus A to P, or O to B plus B to P. What we can first start off by doing is finding A to B, which is minus A plus B, or B minus A. And if we use the first equation, so A to P is 1/7 of A to B, which is 1/7 multiplied by B minus A. And O to P then, if we fill in the gaps, O to A is A plus A to P, which is 1/7, B minus A. So, if we expand and simplify, this is 6/7A plus B/7. Now, we've got that it's 6A plus B in our brackets, so we need to factorize something so that we are left with 6A plus B. So I can factorize out 1/7. And this is the value of T. Now, just to clarify where I get these pathways from, what I am looking to find is OP, so I just need to look at the paths I can take to get there. So, this is this path here, and green is just this way. Both will get you the same answer, but I can use both, and then all I do is I have OA and I have OB, so I just need to find AP or BP, and I just need to fill in the gaps in order to find what my equation is for OP, and then factorize to find out what T is. So our final answer is T is equal to 1 over 7. And that brings us to the end of the paper. I hope that was helpful, and thank you for listening.